Good afternoon, sir.
Yeah, good afternoon, Ron. Okay. So, what is De Morgan's law? De Morgan's law in propositional logic. Anyone? Yes, Nehajit can tell.
Sir, there are a number of laws. So, do you
Yeah,
need me to tell all of those?
yeah, just no. That De Morgan's law only.
Okay, sir. That is for any two given propositions P and
Yeah.
Q. Uh, uh, Negation P. Actually, I forgot. Actually,
Okay. See. Okay. Any other? Can one any say? What is De Morgan's law? That is two equivalent statement. Okay, Mirigan should tell.
Yes, sir. Negation of P, entire negation of P and Q will be
Yeah.
equal to negation of P or negation Q.
Yeah. There is one statement. Another one is
So, negation of P or Q will be negation of P and negation of Q.
that will be equivalent. That means negation of P conjunction Q. That will be equivalent to negation P disjunction negation Q. Another
Yes,
is
sir.
negation of P disjunction Q. That will be equivalent to negation P conjunction negation Q. That is one of the important rules. Okay. P disjunction negation P. That will be always P disjunction negation P or P conjunction negation P. That will be always what? Let us see. Just observe. P whatever the
Five.
phi, not phi.
I
What
said,
is phi?
So P disjunction negation P will be true
Yeah.
and P conjunction negation P will be false.
False. False means no. You don't tell false. That is not true. False. Okay. That
Contradiction.
yeah. You can say that T stands for always true. That is tautology.
Tautology,
T stands
yes.
for tautology, not true. F stands for here. In case of truth values, that T stands for true, F stands for false. But in this laws, T stands
Tautology
for
and
always
contradiction.
contradiction. Yeah, good. Okay, that means some standard laws are there. You have to remember because you have to use in some problems the standard laws or standard laws of equivalences. Okay. Also, last class we have discussed our well form formula, then order of precedence, then that functionally complete set of connectives or logical operators. Okay. Yeah. Okay. See, that is the last portion of this section 1.3. That is also important. Propositional satisfiability. That means, what are the conditions propositional satisfiable? That means proposition is satisfiable or not satisfiable. Not satisfiable means that is called unsatisfiable. Okay, we'll see. A compound proposition is said to be satisfiable if, what is the condition? If there is an assignment of truth values to its variables that makes the compound proposition true. What we got it? See, a compound proposition is said to be satisfiable. What is the condition? If there exists at least one assignment. There is an assignment, that the same meaning is if there exists at least one assignment or one possible cases of the variables. If the variables are PQ or PQR, whatever the possible cases, from the total number of possible cases of the variables. If there exists one assignment or one possible case such that the given compound proposition is true, then we can say that the given compound proposition is satisfiable. Then tell me, we know that the compound proposition are classified into three categories. One is tautology, one is contradiction, one is contingency. Then satisfiable comes which category?
The tautology.
Okay, tautology. That means when it is a tautology. That means if the compound proposition is tautology, then you can say that it is satisfiable. Any other? At least one is true. That means not all false. That means it may be a contingency. That means when the compound proposition is tautology or if it is a contingency, then you can say that the compound proposition is satisfiable. That means at least one is true or all are true, then it is satisfiable. Or all are true means tautology. At least one of them is true. That means it is a contingency. So not a tautology, not a contradiction. Neither tautology nor contradiction, that is a contingency. That means not all are true, not all are false, that is a contingency. So when all are false, that is not satisfiable. When there exists one assignment so that the compound proposition is true, then it is satisfiable. Comes under two cases, tautology and contingency. Okay. When no such assignments exist, That means no such assignment. That means if there exists an assignment, it is true, then it is satisfiable. Then no such assignment exists. That means it is unsatisfiable. That means when the compound proposition is false, is false for all the possible cases, for all assignments. To its variables. Variable is proportional variables. Then we can say that the compound proportion is unsatisfiable. Then unsatisfiable comes which category?
Contradiction.
Yeah. Then see, when we are getting one assignment such that for that particular assignment the given compound proportion is true, then we call them that particular assignment, that is called solution of a satisfiable problem. Just do this. When we find an assignment, assignment means that is the one of the possible case of the proportional variables. When we find an assignment of truth value that makes a compound proposition true, we call that particular assignment as a, that is just for short question, solution of a satisfiable problem. That means for that particular assignment, the compound proposition is true. So we can name that particular assignment that is the solution of the satisfiable problem. Tell me, negation of a tautology. Negation of a tautology is satisfiable or unsatisfiable?
Unsatisfiable.
Yeah, tautology means all are true. Negation means opposite of tautology. Negation of tautology, that means all are false. All are false means it is false for all the assignment. So it is unsatisfiable. Okay. The negation of, it is the same thing. Negation of a unsatisfiable compound proposition. What will be this? Negation of unsatisfiable compound proposition.
Satisfiable.
Yeah, it will be satisfiable. But what is that particular? See,
Tautology.
yeah, it will be tautology. Yeah. That means, see, negation of unsatisfiable. Unsatisfiable means that is a one type of contradiction. So contradiction means all are false. So negation of all are false. That means all are true. All are true means it is a tautology. The tautology means it will be satisfiable. Okay, these are some basics about satisfiable and unsatisfiable of a compound proposition. Okay, then we'll see some example. So that the compound proposition P disjunction negation Q conjunction Q disjunction negation R conjunction R disjunction negation P is satisfiable. You can prove this with truth table. And you can also prove this without truth table. What do you mean by truth table and without truth table? See, with truth table means just find the truth table. P, Q, R is there. Find the whole column of this compound proposition. Satisfiable means, that means, see, I'm just saying that is your work. Find the truth table. For the given compound proposition. Then from the truth table, if you are getting the truth table, show that if it is a tautology or it is a contingency, then you can show that it is satisfiable. If the truth table, that is your work, you have to find. If the truth table shows that the given compound proposition is a tautology or a contingency, then it is satisfiable. That is your home task with truth table. That means when the question is asked, so that the given compound proposition is satisfiable. If it is not asked without truth table or truth table, so you may use the truth table. So find the truth table, and from the truth table, observe that if the compound proposition, if it is a tautology or is a contingency. That means from the column of the compound proposition of the truth table, if all are true, it is satisfiable. If at least one of them is true, then it is also satisfiable by using truth table. Now we'll see how without truth table also we can prove this by just discussion. Okay. Now without truth table, see this. We'll just see, note that, see here, just take one case, will show that if there exists one case or one possible assignment such that the given compound proposition is true, then we can directly say that it is satisfiable. One is true means it is contingency or it may be tautology, so it must be satisfiable. Okay, tell me. We're writing P disjunction negation Q and Q disjunction negation R. Conjunction R disjunction negation P. I'm saying that this will be true when all the three variables P, Q, and R have the same truth values. Then tell me, it is true or false? That means, see, let we are taking P is true, Q is true, R is true. Then what will be P disjunction negation Q? See, P is true, Q is true, R is true. So as disjunction with anyone, disjunction with true or false. So what about the true value? One is true means disjunction.
False.
No, it will be true. See, the bracketed one, P disjunction negation Q, that will be true always. See, you are taking P, Q, R, all are true. All are true means P disjunction negation Q. What will be this? This will be true.
Yes, sir. Yes, sir.
So Q disjunction negation R, that will be true. R disjunction negation P, that will be true. So all the bracketed factors or bracketed propositions will be true. So all are true and conjunction is there. So true, conjunction, true, that will be also true. When all are same truth value. H, P, Q, R, all are false. All are false means negation is there. Negation Q will be true. Negation R is true. Negation P is true. So when all are false, so P disjunction negation Q, that will be true. H negation Q is true. Q disjunction negation R, that will be true. H negation R is true. R disjunction negation P, that will be true. H negation P is true. So all the bracketed factors always true when we take P, Q, R, all are true or all are false. All the bracketed factors are always true. And also conjunction is there. So true, conjunction. So that will be true. That means if we take PQR, all are true or all are false, then the given compound proposition will always true. That means we are getting, here I have written two assignments, all are true or all are false. For satisfiable, if you are getting at least one possible case such that the given compound proposition is true, then you can directly say that that is satisfiable. That means, hence, the given compound proposition is satisfiable. H. There exists at least one assignment of truth values for P, Q, and R. That makes it true. You can just write this, no need to find the truth table. That is the case. This proof is without truth table, just from the observation. So now it's clear what is using truth table. This is without using truth table. If it is not given use truth table or without truth table, so you can use anyone. Okay. Question.
sir, I have one doubt.
Yeah, tell.
Sir, I was finding the truth table. So, P disjunction, conjunction, Q, and that three columns. I mean,
Okay.
sir, what will be the true conjunction, false conjunction, and true? What will be the truth value of this?
No, no. See, you have to find the truth table.
Yes, sir, I did that. But at the end, we are going to find true conjunction, false, and all these type of things are coming.
No, no. See, if you are getting at least one is true, that means see from the last column, if one is true, then it is satisfiable. All are true, it is satisfiable. See,
Sir, last column only I cannot find that one.
no, no. See that. Not that means you are getting what? You are checking this. You are going to find this one. Okay. For this one, for all possible cases of PQR, then just see if you are getting at least one true. I have already checked. When PQR true, then it will be true. One case. Then one case is true means then it is satisfied. No need to check other.
Okay, sir. Okay.
See, it is tautology or contingency. Contingency means what? Contingency means what? Not always, not all are true, or not all are false. At least
So
one
then
is.
in the truth table, we don't need to find the 8 rows.
No, if you are see, if you are finding all the rows, no problem. If the first is true, then you can stop here. Then just write the definition. You can also write this. From
Okay,
the
okay.
definition,
Okay,
if you
sir.
are getting one is true, then no need to find all.
Okay, sir, understood.
Yeah. That depends on the question. If the question is asked, find show that it is a tautology or not. So you have to find all the table, all the rows. For satisfiable, you have to check if there exists at least one possibility or one assignment such that the given proposition is true or false. If there exists one assignment such that the just check one assignment or one row such that for that row the given compound proposition is true, then it is satisfiable. When all are false, that will be unsatisfiable. Only one case. That is the contradiction case. Okay. So that P disjunction Q disjunction R, that is also one of the book problem from book. Negation P disjunction negation Q disjunction negation R is satisfiable. Okay. That is your home task. Okay, now we'll solve some problems from exercise 1.1 and 1.3. Just open your book, exercise 1.1. What is the first question? Just open your book, the textbook, 7th edition textbook, exercise 1.1. What is the question? Question number 1. Just anyone need what is the question number 1? Go to exercise 1.1.
Sir, can you please say the page number?
Page number just after okay, just the discrete methods in application. I think it's page number Just page number, I think 15. 15, 14, 14, 13. Just wait. Starting is
12.
12, 12, yeah. Exercise starting from 12. Page number 12. What is the first question?
Which of these sentences are proposition?
Yeah, which of these sentences are proposition? What are the truth values of those that are proposition? So some sentences are given. Just you have to say that which of these proposition. If it is a proposition, then tell that what is the truth value. Boston is the capital of Massachusetts. So it is a proposition or not?
Yes, sir.
Yeah, yes, it is a proposition. So if it is a proposition, what is the truth value? It is true or false?
So true.
So it is true. Okay. Come to next. Miami is the capital of Florida. So it is a proposition. So what is the truth value? Truth value is false because Miami is not a capital of Odisha. Capital of Florida. Florida is a state of United States. So Miami is not a capital of Florida. So you can write the truth value is false. Okay. 2 plus 3 equal to 5. It is a proposition or not?
Yes, sir.
So it is a proposition. So what is the truth value?
True.
True. 5 plus 7 equal to 10. So it is a proposition or not?
Yes, sir.
Not proposition. Why?
Proposition.
Yeah, it is a proposition. 5 plus
Proposition
7
but
equal.
false.
Yeah, proposition false. See, what is a proposition? It should be declarative sentence as well as it must have a value, means truth value, either false or true. So x plus 2 equal to 11. It is a proposition or not?
Not.
Not a
Not
proposition because without assigning the values, we cannot say that it is a true or false. So x plus 2 equal to 11 is a not a proposition. Not a proposition means we can say the truth value. Okay. Answer this question. Proposition or not?
proposition.
Not a proposition, it's an order. So it is not a declarative sentence. Like this, question number 1, question number 2 is there. Okay. Also to open your book. Okay. See the question number 3. What is the question number 2, like this similar type of question. Question number 3. What is the negation of each of these propositions? First one is May has an MP3 player. So what will be the negation of this?
Sir, May does not have a MP3 player.
Yeah, May does not have a MP3 player. Okay, good. There is no pollution in New Jersey. What will be negation of this?
There
There
is
is
pollution.
pollution in New Jersey.
Yeah, there is no pollution given. So negation of that. So there will be pollution in New Jersey. Okay. 2 plus 1 equal to 3. That means 2 plus 1 is equal to 3. So what will be the negation of this?
2 plus 1 does not equal to 3.
Yeah, 2 plus 1 is not equal to 3. You can symbol not equal to also use. Okay. The summer in Maine is hot and sunny. What will be the negation of this?
Sir, the summer in Maine is not hot and not sunny.
No, just use one not. Don't
Okay, sir,
use the summer. You can that perfect negation will be the summer in Maine is not hot and sunny. That means hot and sunny. One phrase. Okay. Don't write not hot and not sunny. That is not correct. So you may write the summer is Maine is not hot, or that will be not and, or the summer in Maine is not sunny. So don't write not hot and not sunny. That is not correct. So
We can even say it is not the fact that
yes,
the summer.
that is the trivial case. You can use in any sentence. It is not the case that the summer is Maine is hot and sunny. That you can use in any sentence. No problem. Okay. Then go to different type of question. I'm coming. There are some. See the question number 8. See the question number 8. In question number 8, see previous question are similar type of questions. Negation, proposition, all time this. Question number 8, 9, 10, 11, 12, 13, 14. These are some questions. We'll discuss one of them. See, in question number 8, two propositions are given. and we have to express the given logical expressions in term of English sentence. Question number 8. See, let question number 11 just opposite to question number 8. That means in question number 11, two proposition P and Q are given, but the given are English sentences. From the English sentences, we will convert it to logical propositions using PQ along with some connectives that we know. Okay. Question number 8. P given as I bought a lottery ticket this week. Q is I won the $1 million jackpot. First one is negation P. What will be negation P in terms of English sentence? What will be this?
I didn't buy a lottery ticket this week.
Yeah, I bought a lottery ticket this week. Negation P. So that will be I did not buy a lottery ticket this week. Good. Second bit. P disjunction Q. That means P or Q. What will be this? P is given, Q is given. Just use the word or. I bought a lottery ticket this week, or I won the $1 million jackpot. Got it? Okay. Then next is P conditional Q. Then write P conditional Q in terms of English sentence. P is given, Q is given. What will be this? P conditional Q.
If I bought a lottery ticket this week, then I won the $1 million jackpot.
If then, okay, you can use. Just wait. P conditional Q, that means if P then Q. If I bought a lottery ticket this week, then I own the $1 million jackpot. Then P and Q. What will be this? Just write P, I bought a lottery ticket this week and I won the $1 million jackpot. Then P by conditional Q. What will be this? What will be P by conditional Q? Biconditional mean
I won the $1 million jackpot if and only if I buy a lottery ticket this week.
I buy what? You have to write the same.
I bought a lottery ticket this week.
Yeah. You can write also same thing. P even only Q, or you can write Q if and only P. That means I bought a lottery ticket this week if and only I won the $1 million jackpot. Same thing. Okay. F. Negation P conditional to negation Q. What will be this? Negation P means not P, then not Q. That means negation P conditional negation Q. That means if not P, then not Q. What will be this? Okay, see, if I did not buy a lottery ticket this week, then I did not
Did
win
not win the
the $1 million
$1
jackpot.
million jackpot.
Yeah. Like the same way you can find it negation P conjunction negation Q. The last one is negation P disjunction P and Q. So negation P, that will be I did not buy a lottery ticket this week, comma. Use or means disjunction. Then or I bought a lottery ticket this week and I won the $1 million jackpot. Like this, question number 9 also same thing. Some logical expressions are given. P and Q are also given. Just convert the logical expression using connectives to English sentences. Okay. Then also question number 10 is same. P and Q is given. Come to question number, see, question number 8, 9, 10. Same procedure. Question number 11, 12, 13, 14, all are same thing. That means here English sentences are given. We will convert the English sentences in terms of logical expressions. Okay, we'll see.
So can you explain the question number 8 part as so once more?
Question number 8, which part?
H.
H. Okay, we'll see. Okay, just wait. Do question number 1, 2, 3, 4 like this. Question number 8, question number 9, question number 10, same thing. Okay. Question number 8, 9, 10, that is logical expressions to English sentence. All these things. Okay. Question number 8. Which bit? Last one, H.
Yes, sir.
Okay. Negation P, disjunction P, conjunction Q. That is. So P is what? P is I bought a lottery ticket this week. So negation P, that will be I did not buy a lottery ticket this week. Okay. Or disjunction is or. Then P conjunction Q. Then write P means I.
Okay, sir. Got it, sir.
Yeah. Okay. Lottery ticket this week and I won the $1 million jackpot. Okay, tell me, I am telling same question, same P and Q are given. What will be negation P, conjunction P, disjunction negation Q? That type of problem you may face question number 9 or 10. So I am writing this. What will be this? Negation P, same thing. I did not buy a lottery ticket this week. And use the word and. Then P, disjunction negation Q. In this case, use the word either. Either P or negation Q. Either P. P means I bought a lottery ticket this week, or negation Q, not Q, that is or negation Q. Negation Q means I did not win in the $1 million jackpot. Okay. Then come to question number 11. According to question, what is the given propositions PQ?
So is it possible to solve this equation, sir? Then after we can write the sentence.
Yes, yes.
So is it possible to solve this equation, sir?
Solve this equation means which one?
Also this the values, sir.
No, see, in this truth values, I'm not getting it. Just tell what you are wanting, just tell me.
Yes, sir.
See, question number 8,
It
question
is
number...
given a negation P and this is given a negation P and disjunction of P and Q.
Yes.
Sir, the question number is, sir, can we solve this, sir? Sir, as we did with the contradiction part and other equations. So.
Which question? Tell me. Question number 8.
Yes, so question number 8 as part, sir, it is given the negation of P. Yes, the negation of P.
Yeah.
And disjunction P and Q, sir. Is it possible to solve this, sir?
Possible to solve this means I'm not getting. I have already written this. That is the solution.
Yes, sir. This is the question. Means this is solution, but I'm asking that is it possible to have the two values only? Because here is PP and Q. Can we have a
No,
two
no,
values?
see. That is not, you are not finding the truth values. For truth values, it may be true, it may be false. That depends upon the P and Q. It is the English statement. That means whatever it is the proposition. Proposition, we can say that proposition is true. It proposition may be true, proposition may be false. That depends upon the existing proposition P and Q. So we are just finding the English statement. Got it? For finding the truth value, you have to find the truth table. Got it?
Okay, sir. Got it, sir.
Yeah. See, we are finding the English statement, English sentence. That means English sentence is not true. According to PQ, it may be, it is not a tautology always. It may be false. That is a proposition. Proposition is not always true. Okay.
Okay, sir. Got it, sir. Thank you, sir.
P is what is the given propositions P and Q in question number 11? Go to question number 11. What is the given propositions
It is
P and
below
Q?
freezing.
Okay. It is below freezing. And what is Q?
It is snowing.
Yeah. It is snowing. Just see. In question number 8, 9, 10, logical expression to English sentence. But in question number 11, 12, 13, 14 onwards, see here P and Q are given. But in the question, English sentences are given. We'll convert the English sentence to logical expression. Or just opposite to them. Okay. What is the first English sentence?
It is below freezing and snowing.
Okay. It is below freezing and snowing. Then what will be the answer?
P conjunction Q.
Conjunction Q.
Yeah, P conjunction Q. Then come to next question. Next bit. What is it given?
Sir, it is below freezing but not snowing.
Okay. It is below freezing but not snowing. Then what will be the logical expression?
P conjunction negation Q.
Okay, P conjunction negation Q. Why conjunction?
So
See, here
because
is but.
But is used.
Yeah, but you can use but instead of a. That means it is below freezing but not snowing. That is meaning is it is below freezing and it is not snowing. That is the same meaning. Okay. Next, what is the sentence?
Sir, but and not same meaning.
Yeah, in this case, but that is the same meaning as and. Yeah. Okay. Then come to next.
say it is not below freezing and
That
it
means
is
it is not below freezing. That means not P and it is not snowing. So not Q. What is next? Next is
say it is either slowing or below freezing point.
okay. It is either snowing or below freezing. Okay. I think it is given or both.
Yes, sir. P disjunction Q.
Yeah, that is very simple. That is P disjunction Q. What is next? Yeah, just read.
If it is
If it is below
freezing, it also snowing.
Yeah, if it is below freezing, it is also snowing. That means if it is below freezing, then it is snowing. That means P conditional Q. Then what is next?
Either it is below freezing or it is snowing, but it is not snowing if it is below freezing.
Okay, okay, that is the good thing. Either it is below freezing or it is snowing, but it is not snowing if what is given, if it is below freezing, I think. Okay. Then what will be the logical expression to this sentence? See, first one is either it is below freezing or it is snowing. That will be P disjunction Q. Then both is there, both, that is versus and. And it is not snowing if it is below freezing. What will be this? It is not
Negation.
snowing. Yeah,
So
tell
P negation Q.
P conditional to negation Q.
Yes, sir. P conditional to negation
That
Q.
means if it is below freezing, then it is not snowing. That is the same thing. That will be P conditional to negation Q. But on the last, yes, then last one is
That it is below freezing is necessary and sufficient for it to be snowing.
necessary and sufficient. Then what will be this? P is necessary and sufficient for Q. Q is necessary and sufficient. That will be P by conditional Q. Go to question number 19.
Sir, can you show the last line?
Yeah.
Yes, sir.
Okay, go to question number 19. Question number 19 is, some sentences are given. Determine whether you have to use an inclusive or you have to use exclusive or. Inclusive or means disjunction. Exclusive or means this. What is the first question? I think it is. It will be, I think,
Coffee or tea comes with
yeah.
dinner.
Coffee or tea comes with dinner. In this case, you have to use inclusive or exclusive or. That means, see, if both can be happen, then it will be inclusive. If both are not true, then it will be exclusive. Coffee or tea comes with dinner.
Sir,
Is it
exclusive will be when the one will be true, no?
Yeah,
Yes,
it
either
will be
coffee or
at
tea.
least one will be true. So it will be exclusive or. That means coffee and tea both cannot come with dinner, either coffee or tea. So it will be exclusive or directly. Then next one is,
Sir, a password must have at least 3 digits or be at least 8 characters long.
okay. That means a password must have at least 3 digits or at least 8 digits. That means if you take a password of 9 digits, that satisfied both. It is also at least 3 digits, also it is at least 8 digits. So it will be
Inclusive or.
inclusive or. That means when both are true, it will be true. Okay. Then next,
The prerequisite for the course is a course in number theory or a course in cryptography.
okay. The prerequisite course of a number theory or cryptography. That means it is inclusive or exclusive.
Inclusive.
Yeah, it will be also inclusive. Why it is inclusive?
One
Because
can go both.
yeah, if you want students may take or may have both the courses, number theory and cryptography. B. Last one. What is the last sentence? What is the last sentence?
You can pay US dollar using US dollar or euros.
Okay. You can pay using US dollars or euros. Can tell me?
Sir, inclusive.
Ex- exclusive.
Exclusive.
Okay. Okay. Tell me why it is exclusive.
Sir, it can be inclusive also. We can pay using both.
Okay. Well, it will be inclusive. Good. That means, see, you have to pay. You can pay. See, you can pay US dollars or euros. That means you have to pay like 10,000. You may pay 6,000 using US dollar. Rest of the 4,000 using euros. No problem. If it is given that no one can pay both the currencies, then it will be exclusive. So it will be inclusive in this present situation. Okay.
But sir, one should have also means one should have the individual currency,
Hey,
you know.
you see, that depends on the situation, but the perfect or will be inclusive or. If you are using exclusive or, one condition will be there, no one would pay both the currencies. In that case, it is exclusive or, but it is not given. You can pay both. That means some portion of money you can pay using dollar and some other portion of money you can pay using euros. So perfect will be inclusive or.
Okay, sir.
Yeah. So see some question number, I think 27 like this. You have to use find, just practice this, find, converse, inverse, and contrapositive. Converse, inverse, contrapositive. So practice all these things. Question number 27 onwards is the questions containing converse, inverse, and contrapositive. Practice these questions. Okay, we'll do just one more simple problem. Question number 43. That is your work. It is given, find bitwise or. Bitwise and find bitwise XOR. Okay, just I am doing what is the given. Okay, see, bitwise or means or and XOR. We know or means that is disjunction, and means that is conjunction. XOR that means exclusive or. Exclusive or means that is. Okay, what is the bit means? See, when we have used true for true means capital T, false means capital F. Instead of using T and F, if you are using 1 and 0, 1 for true, 0 for false. So that is a bit string. That means collection of 1 and 0s, not true and false. So 1 that is stands for true, 0 stands for false, and all the connectives are same. Okay, what are the given strings? Set B. What is given? Yeah, tell. Question number 43. Bit B.
So 1 1
One
double
one
one double one double zero double zero.
Okay, 0 0 0 0. Then what is the another bit string?
10 10 10 10.
1 0 1 0 1 0 1 0. Bit string means 1 and 0, nothing else. So there are two bit strings are given. We have to find bitwise or. Bitwise or means same. That is the or, only disjunction. But in case of 1 and 0, 1 1 that means true true. What will be this?
True.
Or means what? Or means if any one of them is true, then it is true. That means if any one of them is 1, then it is 1. 1 is
The 0.
1 is 0. How? It is inclusive or in type of.
Okay, inclusive.
If
So what?
at least 1 is 1.
Yes.
1, 1, 1, 1, 1, 0, 1, 0. That means when at least one of them is 1, then or will be 1. When both are 0, it will be 0. The same thing as true and false. Only 1 stands for true, 0 stands for false. Then what will be bitwise AND? That is the same thing, conjunction. Conjunction means when both are true, it will be true. That means when both are 1, it will be 1. Otherwise, it is 0.
It is
And what is
false.
this?
1 0
1,
0.
0, 1,
1 0
1 0
0,
0.
0,
all zeros.
0. Yeah, all 0. That means when both are 1, it will be 1. All are 0. Okay. Then find bitwise exclusive or. XOR means exclusive or means that is exclusive or. Exclusive means exactly 1 is 1. Exactly one of them is 1. Not both 1. Okay. 1 1 will be
0
0.
0.
1
1 0 will be
0
1. 1 1 0. 1
One.
0 1.
1
1
1
0 1.
0.
That is the same thing. Only just keep in mind 1 that is true, 0 is false. Nothing else. Okay. We stop here. So just practice also some more problems from exercise 1.3. Otherwise, you will see 1 or 2 problems in the next class 1.3. Okay, we'll start.
Okay, sir. Thank you, sir.
See, I have solved some of the problems from exercise 1.1. That is your work. You have to solve other problems, similar problems, not all the problems, similar type problems.
Sir,
Okay, I will take the attendance.
sir.
Yeah, tell.
You can send the attendance link again.
Oh, I will give the attendance. Okay.
Okay, thank you, sir.
Sir,
Yeah, tell.
sir 2270 present.
Okay, I will give today all present. Okay.
Okay, sir. Thank you.
Okay,
Thank
sir.
you,
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.